Hello everyone. Today we are going to discuss Millikan's oil drop experiment. For a long time in history, the mass and charge of the electron, which is a lepton and a very nearly dimensionless particle, but which can transfer from one place to another place. Such an electron, such a particle, whose properties were unknown until 1915 around, when R.A. Millikan's oil drop experiment found out the charge of the electron, and thereby multiplying by or dividing by the charge to mass ratio, we get the mass of the electron as well. So this is the apparatus for Millikan's oil drop experiment. We have to determine the charge of the electron. Let's do it. This is an oil bath in the container C. E is the oil bath in container C, and this apparatus consists of two brass plates, the A and B. A has a small aperture in between, and D is called an atomizer, which releases heavy oil, which is non-volatile, which is non-volatile, so this is the apparatus. This is an atomizer. Atomizer is an instrument which converts a liquid form into fine mist of the liquid. So this fine mist, small spherical droplets, fine mist, is produced by this atomizer. Now we can observe that the brass plate B is grounded, and brass plate A is connected to a high tension voltage, that is high tension battery, and this is the oil bath, and here is a small telescope through which we can see oil particles, and this is an arc lamp S. The lamp falls due to the light. The light of the lamp falls on the oil droplets, and then we can see the oil droplets and find out their nature. So this has been going on. Now let's start the experiment. Atomizer D produces a fine mist of particles, fine mist of heavy oil, which goes through the aperture, and because A is high tension, it gets suspended somewhere in the between if we adjust the tension correct. If we adjust the tension correct enough, that we find that the oil drop does not fall with full velocity, it slowly comes and suspends. So here the suspension gives us the idea that there are two forces acting on it. Two forces acting on the oil droplet. Also, I must say, before conducting this experiment, one also can pass X-rays through this optical tubing to even create a better chance of finding out the charge of the electron. This can be done also. But I'll tell you about this suspension. Two forces acting. One is mg, weight of the small heavy oil particle, and the electrostatic force of the high tension brass plate A. Now it is suspended. You have tuned the high tension brass plate to a correct electric field at which it is just suspended. So these two are equal. How do we calculate that? We calculate it by, since the since the molecules of heavy oil are spherical, the droplets are spherical. 4 by 3 pi r cube rho minus sigma g. 4 by 3 pi r cube is always, of course, the volume of the spherical droplets. R minus rho minus sigma. Rho is the density of the oil. Sigma is the density of air in between. And g is acceleration due to gravity. So this is volume, this is density, and this is g. Together it is a force, some force. Now this can be equated to the drag force. I want to pay students to pay special attention here. This force experienced by the electron while going down in their terminal velocity. What is terminal velocity? Terminal velocity is the velocity in which is attained by a particle in a drag environment when it is just left from, or rather without any initial velocity, it is dropped. That velocity is called the terminal velocity. We drop a load, we drop a mass in a drag environment, and when drag up equals gravitational acceleration down, and then that condition is called the terminal velocity condition, and the velocity is called terminal velocity. So we equate this. The idea behind this is that Stokes force is equal to the force by gravity. What is Stokes force given by Stokes drag force? 6 pi eta RV. What is eta? 6 pi you know already. Eta, what is eta? Eta is the coefficient of viscosity of the heavy oil. R is nothing but a radius. V is terminal velocity. Let's go on solving this. Now pi cancel. 3s are, 2s are, R cancel. This is 2. So this has been cancelled. And now we get Now we get 9 eta V by rho minus sigma 2 rho minus sigma G 1 by 2. This is the radius. Now substituting this in 4 by 3 pi r or a cube, we substitute this and we get rho minus sigma. This is called effective mass. This is called effective mass. We have seen this expression just here before I erase this. This expression was there. This is called effective mass. Please consider this. This is called effective mass. Now if this becomes, then we find the mass of this, it becomes 9 eta V by 2, and this is 4 by 3 pi 9 eta V 2 rho minus sigma. You can calculate it yourself. Once you get the formula, it's just algebraic manipulation in order to find out the value. G rho minus sigma. This is the mass. This is the effective mass. Now once we know the effective mass, we know that EQ equals MA, or F equal electric field, and charge into charge equals force. F equals ma. So we need to find q now. The ultimate goal is to find q, charge of the electron. So q equals ma by e. So we have m, we get a multiplied by a and divide by e. Substitute everything and you will find that the value is near 1.602 into 10 power minus 19 coulomb. This is the standard charge of an electron. Standard charge of an electron 1.6 or 02 into 10 power minus 19 coulomb is the charge of one electron. So this is it for today. Thank you very much. Good luck.